and we're back. This is number 2 for the limiting and excising reagents. With this being said, to save on time, we're just going to get started into it. So we're going to give the given, which is 14.4 C2H7N. We're going to multiply that to convert to moles by 1 mole on top, and the mass of this, which is 45.1 grams once it's all said and done. Next, we're going to go to the mole ratio. 8 moles on top, we got that from the CO2 over here, and the 4 moles on the bottom, when we got that from the C2H7N right over there. With that being said, we're going to next move on to the 44.01 divided by 1 mole of CO2 to finally, and those are the grams, to finally convert. Finally, the final answer for that is going to be 28.1 grams of CO2. So now we're going to move to step 2 of this. We're going to start with 63.3 grams of O2. We're going to multiply that by 1 mole to convert to moles, divide it by the overall mass of that, which is 32 grams. Now the mole ratio, 8 moles, we got that from the CO2, divided by the 19 moles, which we got from the H2O. We're then going to go ahead and multiply that by the 44.01 to convert to grams, and 1 mole on the bottom. Final answer there, it's going to be 36.7 grams of CO2. Finally, last step, we're going to have the 14.4 C2H7N times 1 mole to convert to moles, divided by 45.1 grams, multiplied by the mole ratio, which is 19 moles of O2 divided by 4 moles. Then we're going to multiply that by the 32 O2 divided by 1 mole. You're going to come out with a final answer after all said and done in the calculator of 48.5 grams of O2. So now we're going to, what we're going to do is add those up together, and we're going to find the excess here. We're going to take the limiting and subtract it by the 63.3 grams. So it's going to be 63.3 grams of O2, which we got from right there, subtracted by 48.5 grams, which we got from right there of O2. And finally, it's going to bring us to a final answer in the calculator of 4.8 grams of O2. Final answer, easy peasy. We love chemistry. That's it.